Dear students, continuing with review of question paper December 19, January 20. Today we will take up the module number 2. Basically, module number 2 deals with single phase AC series circuit and parallel circuit and three phase circuit analysis. For question number 3A, show the question goes like this: show that in a pure inductor the current lags behind the voltage by 90 degree. Also draw the voltage and current waveform. It is asked for 7 mass. What you have to do is you have to show that in the case of the pure inductance the current lags voltage by 90 degree. For that I am considering here a pure inductance of L Henry is excited by a AC voltage V is equal to V max sin omega t. Because application of this voltage, the resulting current in the circuit is I. Whenever there is a alternating current is flowing through a inductor, it is a property of the inductance that it is opposing change of current that is flowing in the circuit. Thereby there is a induced voltage in the inductance. That voltage what we are calling is back EMF. It is the magnitude of that induced voltage is given by L di by dt. Then if you are applying a mesh equation or KVL equation for this network, then what we are getting is that is whatever the back EMF is producing or inducing in the inductance, that must be is equal to the applied voltage. Then our objective is to establish a relation between the phase angle between the current and the voltage in the pure inductor circuit. Therefore, from this the network, what you have to find out is I. We know the applied voltage V is equal to V by sin omega t. What is the resulting current in the inductance, that you have to find out. For that, I am considering your pure inductive circuit excited by a AC voltage, and it is given by V is equal to V max sin omega t. Then I will call this as equation number 1. That is applied voltage. Then because of application of this voltage, the current I will be flowing through the inductors, and because of the nature of the inductance or characteristics of a inductance, then there is a back EMF is inducing in the inductor, that is given by L di by dt. This back EMF at every instant opposes the change in the current. That is a property of the inductance. Then the applied alternating voltage must be equal to the induced back EMF in the inductors. Therefore, the applied alternating voltage must be equal to back EMF. Therefore, what I am substituting here is for applied alternating voltage is V max sin omega t and induced voltage in the inductance is L di by dt. Then from this equation, what I want is the current equation I. Therefore, I am writing the equation for di in terms of other variables. That is, I am keeping di as it is. The rest of the terms I am transferring to the other side. Then what I am getting here is from this equation di is equal to V max divided by L into sin omega t into dt. To get I, what I have to do is I have to integrate both sides so that I am getting I. Therefore, integrating on both sides, then the left hand side what I am getting is integration of di is I. Then here I am integrating V max by L is a constant term, then integration of sin omega t dt, what I am getting here. Then the constant V max by L is as it is, and the integration of sin omega t is minus cos omega t divided by omega, that I am attaching to the value L. Therefore, after integrating this equation, what I am getting is the current I, that is equal to V max by omega L into minus cos omega t. I am expressing this cos omega t in terms of the sin omega t, that what I am getting here is the current equation I max sin omega t minus 90. This is the equation number 2, where V max by omega L, that I am calling as a I max. Then if you are comparing the equation here, the base is the omega t, then the current I is omega t minus 90. It clearly shows that the current I lags the voltage V by 90 degree. Minus 9 represents the lagging current with respect to the reference voltage V. Therefore, it shows that the current lags the voltage by an angle of 90 degree. That is the same thing as written here. That is the current lags the voltage by pi by 2 radians or 90 degree. Hence, in the pure inductance, current lags the voltage by 90 degree. Then he asks you to draw the voltage and current waveforms. Therefore, first you have to draw the voltage waveform with the 0 reference. Then 90 degree lag you have to draw the current waveform. See here, this is the voltage waveform. Then the current waveform start from 90 degree onwards. Therefore, it is lagging the voltage P by an angle of 90 degree. Then there is a waveform will start. Therefore, these are the two waveforms for voltage as well as for the current. Then we'll move to the question number 3b. It is on the single phase circuit. Is given the voltage and current in terms of sinusoidal form. That is, voltage V is equal to 200 sine 377 t volts, and the current what is given is 8 sine 377 t minus 30 degree. Then he asks you to find out the power factor, true power, apparent power, reactive power, and also he has to ask you to indicate the units of each power. Okay. Then when if you are talking about the power, then you must have the RMS value of voltage and the RMS value of the current. Then if you want to calculate the true power, we want the power factor also, that is the phi we want, then we want the phase angle. To calculate this power and the power factor, what you have to calculate is VRMS, IRMS and the phi. Then how to get it? All those parameters from the given equation that we'll see. That is the given the quantities are V 200 sine 377 t volts, I is equal to 8 sine 377 t minus 30 amperes for an AC circuit is given value. Then you have to determine the power factor, true power, apparent power and reactive power. The first what I have to calculate is VRMS and the IRMS, and I want to calculate phi. Then how to get VRMS? Then just you have to note down the given quantity, that is V is equal to 200 370. Then you compare with the standard equation V is equal to V max sine omega t. You come to know, if you are comparing this, then the V max is equal to 200. Once we know the maximum value, you can calculate the RMS value. That is, RMS value is equal to maximum value divided by root 2. Therefore, you write the given equation in sinusoidal waveform. At the same time, you have to write its standard form and you have to compare the quantity. Then you will get the results. Therefore, Vmax is equal to 200 volts. Then Vrms is equal to Vmax by root 2. Therefore, it is 200 by root 2. Therefore, the Vrms what I am getting here is 141.42 volts. It is very simple. You have to compare the given quantity with the standard form. Similarly, I will go for the current also in a similar fashion. That is, I is equal to 8 sine 377 t minus 30 is given minus 30. Therefore, I am comparing with this I max sine 3 omega t minus the phi, because here minus 30 is taken, I am taking here minus phi. Then if you are comparing these two equations, the Imax is nothing but 8, therefore the maximum current is 8 amperes. Then the RMS value of current is Imax by root 2, thereby what I am getting here is IRMS is equal to 5.65 amperes. Then you compare the voltage and the current equation here. The base is 377 T, however the current is 377 T minus 30, means with respect to the reference, this current I lags an angle of 30 degree because it is a minus 30 degree. Therefore, if you are comparing these two equations, the current I lags the voltage by an angle of minus 30. Therefore, my phase angle difference between the voltage and the current is 30 degree. Therefore, that you have to note down here. Angle of lag phi is equal to 30 degree. Then power factor, how you are finding out the power factor? He asked the first thing is to calculate the power factor. Power factor is nothing but cos of phi, that is equal to cos of 30, therefore it is 0.866 lag. Then the next thing is what he asked is true power. True power means it is a power consumed in the circuit. That is P is given by Vi cos phi. That equation you have to write. P is equal to Vi cos phi. Then you substitute the value of V and I. V and I are the RMS value of the voltage and the current you are already calculated here. Therefore, cos phi is also calculated here. Just you have to substitute the values, then find out the true power. That what we are getting is 691.95 watts is the true power. Then second thing what he asked is apparent power. Apparent power is nothing but it is a product of the voltage and current. It is measured in terms of volt amperes. Then once again we know VIRMS, IRMS, substitute the value, then find out the apparent power. That what we are getting is 799.02 volt ampere is the apparent power. Then the fourth quantity what he asked is the reactive power. Reactive power is nothing but it is a product of the voltage, current and the sin phi. Therefore, if you are substituting once again the values, then what you are getting is the reactive power in the circuit is 399.5 volt ampere reactive. It's a very simple. Just you have to note down the equations, compare with the standard format. We are getting the maximum value. From the maximum value in turn we have to calculate the RMS value. Then we have to find out the power factor angle or cos phi. We have to find out. Then we have to find out true power, apparent power and reactive power with the appropriate formulas. Then we'll move to the question number 3C. It is on three-phase circuit. Here three similar coils each having resistance of 10 ohm and reactance of 8 ohm are connected in star connected across 400 volt three-phase supply. He asks you to calculate line current, total power, reading of the two wattmeter W1 and W2 measure the total power. Once again he asks you to calculate the current. To know the current, then what you have to do is you have to apply the V is equal to IZ formula. Therefore, V is given, he asks for the I, then you have to calculate the Z from the given data. Therefore, the given data is it is a star connected, per phase resistance 10 ohm is given, per phase reactance 8 ohm. The line voltage is given 400 volts. It is a star connected. All the calculations are made per phase basis. This line voltage must be converted into a phase value. Okay, first you calculate the impedance. Impedance is given by Rp square plus Xp square under square root, so that I am getting 12.806 ohm is the impedance of the circuit, per phase limb. Then the per phase voltage, it is a star connected, it is VL by root 3, therefore what I am getting is 230.94 volts is the per phase voltage. Then what I am interested is the line current. You are not getting the line current directly. First you calculate the phase current, then you have to find out the line current. Therefore the IP, how we are finding out? IP is equal to Vp by Zp. Vp you are already calculated, Zp also calculated, just you have to substitute the value of IP at Zp. Then what I am getting here is the per phase current is 18.033 amperes is the per phase current. Then it is a star connected. We know that the relation between the line current and the phase current and line currents are same in the case of a star connection. Therefore, IL is equal to IP is equal to 18.033 amperes is the line current. That is the first thing. That is the line current he asked. Then he asks you to calculate the total power here. The total power in the three-phase circuit is single phase power is VPIP cos phi. Then it is a three-phase circuit, it is 3 VPIP cos phi. Just you have to write the equation. P is equal to 3 times VPIP cos phi. We know the Vp, we know the IP, and we know the value of the power factor cos phi. How? You have to calculate the cos phi by Rp and Zp. That is cos phi is Rp by Zp. I am calculating here. See here, cos phi is equal to Rp by Zp. Rp is known and Zp is also known. Just you have to substitute. then what you are getting is 0.7808. That you have to substitute in this equation. What I am getting is the power is 9746 watts. It is straightforward. Just P is equal to 3 Vp Ip cos phi. We know all the quantities. We know the Vp, we know the Ip, and also we are having the cos phi value. We are calculated the total power consumed in the circuit. Then he asks you to calculate what is the wattmeter reading of W1 W2 if they are used to measure the three-phase power. Then we know that the relation for W1 and W2 while measuring the three-phase power using two wattmeters are, that is VL IL cos 30 plus phi, that is the reading of the first wattmeter. The second wattmeter reads VL IL cos 30 minus phi. We know the VL, that is a VL, we know the value of IL, and also we know the value of the phi. Just you have to substitute and you have to calculate the W1 and W2. So that the first wattmeter reads 2627 watts, whereas the second wattmeter reads 7119 watts. If you are adding these two wattmeter readings, you have to check such that W1 plus W should be is equal to the P. The sum of these two wattmeter is equal to this P. This is how we have to solve the numericals on the single phase AC series and parallel circuit as well as three phase circuit. In the next session we will take up question number 4. Once again it is on single phase AC series and parallel circuit and three phase circuit.